Hi there, this is a question from the 2016 Exam 2 from the Geometry and Trigonometry section, and it is question 5b. So, a sprinkler can water a large area of grass. The sprinkler will water a section of grass as shown in the diagram. So the section of grass is the shaded part here. The section of grass is watered is 4.5 metres wide at all points. So 4.5 metres wide. Water can reach a maximum of 12 metres from the sprinkler at L. What is the area of grass that this sprinkler will water? Round your answer to the nearest square metre. So this is a 2-mark question. So there's 2 ways that this question can be done. You could calculate the area of a large circle, area of a small circle, subtract that away, and also subtract the area that is not there. However, if you can identify that this is also a sector, it actually makes it a lot easier. So because when we have a look at our notes, quite often you'll look at the sector is kind of like the size of a slice of pizza. And in your head you're thinking that a sector is just a small part. A sector can also be the other part of the shape. So in this case right here, it can be the white area. So you just need to know what that angle is. So in this case, if that angle is 100, then the angle that goes all the way around here is 260 degrees, because we know that a full circle is 360. So by now, it makes it a lot easier that you can use this as an area of a large sector with an angle of 260 degrees. The next step is through calculations is understanding what steps you need to go through and what you subtract from what to get to the answer. But a way to look at this is, if this was a donut, how do we get a hole in the donut? Well, if in real life you'd remove the center out of the donut. So with this question you can work out the area of the outer circle sector. You can work out an area of the inner circle sector, and then you could remove that inner circle away, just like a donut, take out the middle. So let's have a look at finding the information that we need to do both those calculations. So I'm going to right now draw a line down the middle of my page, and I'm going to call this the small sector, and I'm going to call this one the large sector. And this will allow us to do our 2 calculations and then calculate our answer over here. Alright, so the first thing we need is our formula. So we've got the area of a sector formula here, which is pi r squared times theta over 360. So let's just write this over here. So area equals pi r squared theta over 360. And we'll use this formula in both these sections. First off, the small sector. Let's work out what the radius of the small circle is. So what the radius we're talking about is from here out to there. That's our radius that we're looking at. We're looking at this white circle. So the question's told us it's 12 meters all the way across to the outside, and it's also told us that the grass is only 4.5 meters wide. So to find this radius, it's going to be 12, the difference of the 12 minus the 4.5. So if we do 12 minus the 4.5, this will give us a radius of 7.5 meters. And we'll use this radius to calculate the area of the small sector. So let's place this in, all the information into our question. So we have area is equal to pi times 7.5 squared, don't forget the square, times by degrees of 260. It's not 100 because we're using this larger sector, over 360, and our area would equal for the small sector 127.6272016. And I'm not going to round it until the end, and that is meters squared. Let's do the calculations for the larger sector. So we're going to calculate the area of this whole shape given for this area, for this sector. So area is equal to pi times our radius squared, and our radius is from the center out, which is 12, so pi times 12 squared, times by our angle of 260 degrees, because once again we're using that larger sector, over 360. Our area would equal 326.725,636. Like I said at the start, if this was a donut and we were trying to work out the area of the donut, we'd have a large big circle of the donut, and we would remove the center, leaving a hole. And that's what we need to do. We've got the larger area of the sector given. We've worked out the smaller sector in the middle. We're going to remove that smaller one from the large one. So if we did 326.725,636 minus 127.6272016, this will give us an area of 199.098 meters squared, and in our question it's asking us for the nearest squared meter, so this would give us the answer of 199 meters squared, which would be our answer here. Let's have a look at the assessor's comments for this one. 199 meters squared was given there, and only 22% of the cohort managed to get the full marks for this one. 2% managed to get 1 mark, and a large 75% of the cohort couldn't even get the 1 mark. So 75% of the cohort could not even do a calculation of identifying using this formula and even getting the area of a small or larger sector. And that's what 1 mark would have been given is here, and the second mark would have been this calculation here, which I think is a pretty poorly answered question for very simple calculations. It's just understanding what you need to do with those calculations. I think a large number of students might have even used the 100 degrees in here and then done a subtraction after they used the 100 degrees. But if you can manage to be in that 22% of the cohort that got the full marks, that is fantastic. And this question doesn't even rely on any information from Part A either. So there's no excuses as to not being able to find the answer in Part A and implementing it in Part B. So this is nearly a standalone question, being 5B. Hopefully you've learned some things here that might help you if this question does pop up on the exam. Thank you.